of mammogram images for breast cancer detection, starting with the original images here. The first one is about the original images and then undergoes median filtering to reduce the noise, enhance the clarity, and also enhance the clarity and highlighting the critical features like tumors. Here you can see, and next one we apply the histogram equalization. And after that one, you can see here, boost the image contrast and making it easier to detect the suitable difference in the tissues and density. You can see here, you can see the suitable density over here. And then next one is to specify the region of interest. And these areas potentially contain abnormalities. The surrounding background is removed to focus this only on the region of interest here. Now you can see here, these are our region of interest, and these are our ROI patches. Then we divide into the patches. And furthermore, next one we use here Grey Wolf optimization again for the hyperparameter optimization and extreme learning machines for the classification for the breast cancer classification into beginning, malignant, and into the 3 different classes. And here we use different type of fusion techniques, like for the feature fusion, and then we finally apply the classification model. And here is the performance of the GW quantum gray genetic binary Grey Wolf optimizer. You can see here in this imaging, optimizer effectiveness on the various benchmark functions. We use here 10 benchmark functions, which are already available in the Miraj Jalil GW paper. From there, we can choose the 10 benchmark functions and apply all these 3. All these for 3. First is GW, and then BGW, and then quantum genetic binary Grey Wolf optimizer. We'll compare all of these performances, and in the end, we can see the visualization help in evaluating robustness and the speed of convergence of QGW algorithm, highlighting its capability to find optimal solution effectively across the varied complex problem sets. And here are the ROC curves, and here we can see that the QG, BGW, and base BCNet across the multiple diagnosis categories, normal, beginning, and malignant, and also Markov category. Each plot reveals the true positive rate and the false positive rate here to different classifier, providing insight into the model accuracy and diagnosis medical conditions. And the next work here is again about the diabetic retinopathy. This one based on the CNN SVD. CNN means SVD single value decomposition, used here for the feature reduction. Following in the first step here is the following the segmentation image, original image, then pre-processing, and then here's a segmentation procedure. And further, then we use it for SVD for the decomposition, like they choose the best optimal features, and then finally classify it using 3 different modules here: improved SVM, RBF, polynomial, and linear. We use 3 models from the SVM: improved SVM, RBF, SVM linear, and SVM polynomial, and we use the voting system with the binaries and the KNN. And then finally we classify it into 5 different stages. And future trends, outline the future trends in medical imaging, especially the advancements in imaging technology. It highlights 4 key areas: an increase in resolution for clear and more precise image details, like further now we using spectral or hyperspectral imaging, faster processing speed due to enhanced computing powers and algorithms, along near real-time analysis, improved data analysis capabilities through the integration of AI and machine learning, enabling more effective information extraction. And also the role of this technology is driving an industrial intelligence and suitable development across the various sectors. And here, finally, here's my conclusion. In conclusion, the presentation explored the significant impact of AI and machine learning on the healthcare. We use different type of models, and also we use the different optimization algorithms like the GWO, Grable Optimizer, to enhance the performance of the classifier by optimizing its hyperparameter tuning. And also we detect the different disease like the breast cancer, diabetic retinopathy. And currently nowadays, we are working on different diseases like the image registration and image enhancement, also image regeneration. And we are working on in 3D imaging, as well as also we are working on some real-time application as well. Okay, everyone, this is done from my side. Thank you very much.
Thank you so much, Dr. Anas Bilal, for giving a wonderful session on the role of AI in medical imaging. And I hope there will be a question from the audience. Any
Yeah,
questions from
sure.
the audience? No, sir. Thank you so much, sir, for presenting a
Thank you.
wonderful session. I hope. Thank you so much, sir.
Challenges and Opportunities by Dr. Tanveer Alam. Dr. Alam is an assistant professor at the College of Science and Engineering. His research work is centered around the application of artificial intelligence in the diagnosis and prognosis of communicable and non-communicable disease. His works aims at risk factor stratification, enhancing diagnosis accuracy, and promoting personalized treatment plans for conditions such as diabetes, obesity, cardiovascular disease, and lung cancer. His vision is to establish an AI-enabled personalized healthcare system for the community at the large scale.
Assalamu alaikum. Can you hear me?
Assalamu alaikum, Doctor Sahab. Are you listening me?
Yes. Thank you very much for the organizers, ICOSST, for this event.
I'm audible, Doctor Sahab.
Can you hear me? Can or you cannot hear me?
Uh, Doctor, there is a voice issue from your side. No, sir, I'm not hearing you.
Should I continue?
Yes, sir. You can continue and proceed.
Okay.
Thank you.
You can see my screen, right? So thank you for the organizers for providing me this opportunity to this ICOSST conference. Tanveer, Associate Professor at HBK Hamad City at Qatar. So we are part of Education City in Doha, and this is a snap of our campus. And you can also see one of the stadium next to our office. In our university, we have 6 colleges. I'm part of the College of Science and Engineering. And we have also some research centers like Qatar Computing Research Institute, Biomedical Research Institute, Environmental, etc. So today I will try to talk more about our work on the precision health initiatives. So we have a complete ecosystem in our university under Qatar Foundation. We have educational programs, 2 specific programs for health, Masters of Data Analytics and Information System in Health. We closely work with local hospitals, private hospitals, as well as public hospitals. We have recently established 2 research centers, Essence Autism Sensing Center. And our ecosystem provided us to support the development of health-related startup as well. And we also developed the technology, and we have multiple research pillars in it. So today I'll go to talk very briefly. I will talk some work on cancer as well as some non-communicable diseases. Then finally, we'll talk about the challenges we are facing in implementing healthcare related projects in the industrial level. So this is the overall stats of the prevalence of Qatar cancer patients. And you can see more than 15% female patients having breast cancer.
Okay,
For the
okay.
male, colorectal cancer is the most prevalent one. And for other types of cancer, lung cancer is the most severe one. The survival rate of lung cancer patients are really low. It depends based on the staging from stage 1 to 4. It may vary from 1 year up to maximum 3 years. And Qatar has started working on the adoption of AI in the primary healthcare centers. They have recently launched AI-enabled solution for breast cancer for the female as well as bowel cancer for the primary healthcare centers for the community. In this work, we are working closely with our public hospitals, Hamad Medical Corporation at Doha. So currently, the early screening protocol is the low dose CT scans. And people having the history of smoking or who have quit the smoking for the previous 5 to 10 years, they have gone through the PHCC at the primary center. And based on that screening, they referred the patients for further screening. So to improve that screening process, we have developed an CT scan-based approach for the detection of lung cancer, because low-dose CT scan is the norm here for the community level. So we, to support that initiatives, we have collected data from publicly available data set. And as usual, Dr. Anas also mentioned some nice talk on the power of AI on the imaging. So we applied some techniques. And based on those imaging data and deep learning models, we really got good results. Now we are trying to incorporate that solution in the clinical trials. But as I mentioned, once there is an onset of lung cancer, it is unfortunate the survival rate is really low. And once the stage progress from stage 1 to stage 4, it's almost a miracle if the person or the patient survive for more than 18 months. Here you can see the survival rate of lung cancer patients at different stages. And you can see at the stage 4, they barely live for more than 18 months. So that's why we need a proper treatment plan to extend the longevity of the patients. And the drug that are prescribed and that are approved by FDA, different TKI, we call it tyrosine kinase inhibitors. And it depends upon the mutation on the genes. So on the left panel, you can see some classical mutations like exon 19 mutations on EGFR gene L858R point mutation and other type of mutations. And these are kind of common standard in the clinic, this type of drugs that are prescribed and treated. But for other rare mutations that are not common across the patient, there is no specific FDA recommendation. So that's motivated us to move our second project on along the same direction. So what type of medication that can be prescribed based on the condition of the patients? So we used our study on one of the drugs, first generation drug, gefitinib and erlotinib. And we check the patient's history and their genetic profile as well as their mutation. And then we try to model these genetic mutations along with the FDA-approved drugs. And what is the drug response? Are the recommended drugs are helping or reducing the tumor growth? Is the tumor is completely disappearing or partially disappearing, or the disease is stable or not? Based on that, we developed an AI model. First, we collect all the data. We have relatively smaller cohort of roughly 200 patients, but they are coming from different stages and different types of mutation. Majority of the mutations are very common. And we do the MD simulation and molecular docking of the FDA-approved drugs over the EGFR and mutations, and we model them using the standard protocol. And then we also identify some key geometric features based on the drug and the protein interactions. So based on this, we developed our model based on some morphological features, as well as the simulation results from the drugs and the target EGFR. And then we feed those information into the model, and based on those features and clinical information, our model was pretty good on the detection of the staging of lung cancer patients, which clearly helps us to recommend this model for the doctors or then the clinics to prescribe any drug. They may have an idea what might be an impact after prescribing this drug for different stages of the patient. And we also compare against the state-of-the-art paper, and our results are reasonably well. So this study, we work on the existing drugs, but as we mentioned, for non-classical or atypical mutation, there is no FDA-approved drugs. So we also need to work on drug discovery. So that's why in this project, we work on novel drug discovery for the cancer patient, but here we focus on cancer that has been metastasized. So in metastasis, the survival rate is further low because cancer progress and spread across different organs on the human. So for this purpose, we similarly use the molecular docking and MD simulation approach on the target genes. So what we did, we collected the data from TCGA, the Cancer Genomic Atlas. And from there, we collected the expression profile of lung cancer patients, and we compute their expression and then identify the differentially expressed genes. So out of the 385 differentially expressed genes, we rank them based on the log fold chain and the p-values, and we select the top 2 genes. And then we select the molecular docking approach for open source chemicals that are available in the literature. And we prepare the ligand and protein, and we made the protein ligand docking, and we see the visualization. So these are the kind of the outcome we got. So we, as we mentioned, we have roughly 358 differentially expressed genes, and we select the top ranked 2 genes, TFF2 and REC4, and then we do the molecular docking to check the drug and target binding affinity. We take the FDA-approved drugs, first-generation drug gefitinib, as well as chemicals, novel chemicals from Selechem anti-cancer compound library. And interestingly, we found 3 anti-cancer peptides that are having higher binding affinity than the FDA-approved drugs. So this gives us initial hints. So we are now further doing on the lab validation on these findings. So this helps us to understand the power of computation with the support of lab-based experiments to mitigate the progression of the cancer as well as the novel drug discovery. But we also focus on not only cancer, but other non-communicable diseases like cardiovascular disease and diabetes. And cardiovascular disease, we all know this is a global issue. More than 70% of the deaths are coming from the non-communicable diseases, and majority of that is coming from different form of cardiovascular diseases. The traditional approaches are for cardiovascular detection is ECG, echo, X-ray, etc., etc. But they are quite expensive, time-consuming, as well as invasive. So here in Qatar, we have taken an initiative to identify non-invasive approach, which for the early detection of cardiovascular diseases. So here we are focusing on two modalities, one based on fundus imaging, ultra-wide view and regular fundus imaging, as well as DEXA imaging, which captures the whole body scan for your fat, muscle, and the bone density. So these are completely non-invasive. And using these multimodal non-invasive modalities, we build our model on Qatari cohort, and we get reasonably good results. We got roughly 80% accuracy on the early detection of the cardiovascular disease. Then we also check the bone health condition because in the literature there is still not clear whether the long-term diabetes has any impact on the bone health, like which may lead to osteoporosis or osteopenia, etc. For that, we collected Qatari cohort who are having diabetes for more than 15 years, 10 years, or 5 years. We have cohort at different level of the prevalence. And based on their bone health analysis from the DEXA machines, we found that lower bone mineral content and bone mineral density in different anatomical region of the body parts of diabetic cohort are there, but those differences are not statistically significant. So we conclude that though diabetes has some impact on bone health, but the impact is not that severe for 5 to 15 years of diabetic prevalence patients. Then we also work on another disease, diabetes detection. This is not diabetic retinopathy, but pure diabetes detection. People may or may not have diabetic retinopathy having diabetes. Okay, if they are well controlled, they may not have the diabetic retinopathy. So the current standard, gold standard, is HbA1c for detecting the diabetes. But glucose is also used, but glucose is not the gold standard because it may fluctuate over 20 hours of time. But HbA1c is the 3-month gold standard for accumulated sugar level, but it's quite expensive and time consuming as well. So to overcome that approach, so we collected and initiate a project with Qatar Biobank. We all local residents in Qatar, and we also collaborate with public hospital, Hamad Medical Corporation. So we have developed AI model for the early detection of diabetes using Qatar Biobank data and validated on Hamad Medical Corporation on cohort. So our model based on this cohort and in the hospital achieved really good results, having almost having 90% accuracy of detection of the diabetes, type 2 diabetes. So these are some common tools and AI technology that we used for cancer care, as well as non-communicable diseases like cardiovascular disease and diabetes. Now, what we do in our lab, so we collect the patient's data as well as then build a model. Then we go for the clinical validation. And in the clinical validation, there are multiple phases, phase 1, 2, 3, 4. But that's not the story, end of the story. To ultimately transfer your AI model into industry, so you need to take a long path. And this pathway is really complicated, time consuming, as well as very expensive. Here I will show you statistics from last year. The list of AI or machine learning enabled medical devices that have been approved by the FDA, which is the body for American Society for any type of medical devices or solutions. So you will find only last year, only less than 1,000 solutions that have been approved so far by the FDA, which clearly indicates that though we are developing AI model, we are going for collaboration with some clinics and hospitals. There is a clear gap between what is done in the lab and what is ultimately transferred as a technology in in the in the market. You can see only 1,000 solutions that has been approved so far by FDA till November last year, 2024. And we also check the list of approved solution this year, and we found this number has increased from 1,000 to 1,250. So that means roughly 250 more solutions has been approved by the FDA. And you can see the majority of the solutions are 75% are radiology solution because deep learning models really work on imaging.
Dr. Tanveer, sir, hope you are
Yes.
listening. Sir, basically, sir, we have very short time, so we have to conclude this topic on.
Okay, so then I'm going to the last slide, okay? Last
Yes,
slide.
sure, sir.
Okay, so this is the overall timeline and the cost for transferring any AI model from lab to the industry level. It takes at least 3 years to 5 years, and the cost is around 250,000 euro to 500,000 euro. So that's a really time and time demanding as well as monetary demanding. So what are the call for action? This is my last slide. So we need to raise awareness among the healthcare researchers, how to transit from lab-based to the industry-based solution. We need to reduce the communication gap between policymakers and researchers. So, and finally, we need to make a lot of workshops, symposium to reduce the gap between the different stakeholders in the community. So I would like to acknowledge the funders and my colleagues as well as the students. And thank you so much for providing me this opportunity to be part of this nice conference. If you have any question, please feel free to ask.
Dr. Tanveer, there is any funding opportunity for the students or collaboration with UET?
Definitely. We are open for collaboration, and as well as we have funding opportunities for students exchange as well as for faculties. If we can initiate a collaborative projects, we can also fund that for sure.
So thank you very much. Thank you.
Thank you so much, sir. Sure, we will be in touch again, and thank you so much for giving wonderful session on
Thank
AI
you so
drive.
much. Thank you. It was a pleasure. It was a pleasure. Thank you.
Now we have interesting format Dr. King servers with the title of Sustainable AI, Intelligent Computation with Purpose, Precision, and Efficiency. Dr. King server is a distinguished researcher and academic specializing in artificial intelligence, machine learning, IoT, and energy efficient computing. He has authored numerous research papers in international journals, the IT, active methods, and computing materials and media. Recognized for his outstanding academic and research excellence, he has received multiple international and national institutional awards. And IE senior member Dr. Sarwar serves as commissioner editor for International Journal of Agriculture and Application and holds an important position in leading journals such as Security and Communication Networks, IET software, and journals of healthcare engineering. He is also a reviewer for prominent journals by IET, Elsevier, Springer, ACM, and MDTI, and a leading test editor for established international special issues. He is a proud member of the Cambridge Association of Research Educators, cross-cultural fellowship and engagement. He is promoting global collaboration and sustainable innovation in intelligent computing.
Assalamu alaikum, everyone. I am hearing you.
Assalamu sir. How are you?
Well, Alhamdulillah, fine. Ji. I am audible?
Yes, you are audible. Sir, you can proceed.
And my screen is also sharing. So, Assalamu alaikum, everyone. My title is The Suitable AI, Intelligent Computation with Purpose, Precision, and Efficiency. And I'm Dr. Nadeem Sarwar from Bahrain University, Lahore campus. And I am a senior member IEEE and also the member of Computation Intelligence Society. And I'm also the member of Caveat Association of Research Educators, Cross-Cultural Fellowships and Engagement, Philippines, promoting global collaboration and sustainable innovation in intelligent computation. I'm also editorial board member of various impact factor journals like IET Software, Journal of Healthcare Engineering, and many. So the abstract of my talk is the AI is transforming industries, yet it is growing computational demands raise serious concerns about energy consumption and sustainability. So sustainable AI focuses on the designing algorithms and computational infrastructure that minimize energy use, optimize resources, and ensure that every bit of the computation serves as meaningful purpose. So from cloud to edge computing architectures to define prompt engineering is a large language learning models. Efficiency is becoming a key metric, not just a performance, but in the environmental responsibility. So in the light of these points, the main focus of my presentation is model performance and the environmental responsibility. So, as per the Sustainable Development Goals, we have these 17 SDGIs where the climate action and energy, green, clean energy, affordable and clean energy, also the part of these SDGIs. And we can use these all of the resources like edge, DevOps, deep pipelining, TPU, LMO, specific boards. These are all relevant to the energy efficiency. And also the software optimization, quality of the solutions, compilers, reputation of the complexity, also related to the field of the energy efficiency. And in the field of cloud, virtual machines, task scheduling, and the resource management, also the part of the energy efficiency research theme. And the GPU and CPU, where we have used many task scheduling softwares, workload distributions, also required efficient energy consumption. So this is the summary of the system in which energy efficiency has been approached. So the era of intelligence, AI and digital transformation are reshaping every sector, yet growing AI workloads consume massive energy resources. For example, training a large AI model can emit such much carbon as 5 cars in their lifetime. So you can guess the utilization of energy uh, discussed in this example. So we are facing some challenges. How do we make intelligence sustainable? This is the question for all audience. How do we make intelligence sustainable? So what is the sustainable AI? Designing and deploying AI systems that are energy efficient, ethical, and responsible. So balance performance with planetary well-being required. So integrated principles of green computing, if we can integrate green computing principles and energy optimization techniques into the AI design, we can achieve sustainable AI. So our objective is the smarter computation with minimal ecological footprint. So green computing is the backbone of the sustainable AI. So we need to focus on energy efficiency, sustainable design, visualization, and cloud efficiency to reduce redundant resources use. Because when we use such type of resources, we need to use sustainable concepts. So in e-waste reproduction, we need to responsible disposal and recycling of our applications. So this is the concept of green computing. So green computing promote environmental sustainable practices, which will applying using IT resources. So we can emphasize on energy, waste reproduction, and eco-friendly environment. So computational intelligence needs sustainability. So when we design AI models which can optimize their own energy use, like adaptive learning algorithms that regulate GPU utilization. We can also use AI for energy management, like predictive maintenance and like smart grids and like demand forecasting. We can shift from bigger models to efficient for used and adaptive models. So many programmers nowadays used bigger models, but they are not focusing on efficient focusing and adaptive models. So we need to design efficient and adaptive models. So how we can design such kind of adaptive models? So we need to focus on edge computing, which is the process data near IoT devices, reduce latency and energy uses. So when we put a query to our system, we can use a lot of billions of edge devices and fog nodes. Millions of fog nodes used and millions of edge devices are the part of that query. So when our query enter to the system, the cloud data resources pass our query to the fog nodes, and the fog nodes pass our query to the edge devices. So a lot of edge devices utilize energy resources. So that's why if we use efficient algorithms and model designing, obviously we can reduce our energy consumption. So model comparisons like quantization and pruning reduce energy cost. So our focus is to reduce energy cost. So for this purpose, we also can use federated learning like distributed AI without central data storage. This concept is also very popular nowadays, federated learning. We can also focus on the auto machine learning and neural architecture search for optimized resource utilization because these type of algorithms help us to reduce energy cost. So trade-off between accuracy, interoperability, and efficiency will achieve when we manage efficiently our algorithm. So we need also to design refined prompt engineering. So refined prompt engineering means when we use language learning models that are that depends on high computation prompts drive cost. So efficient prompt, when we do efficient prompting, we will achieve efficient computation. So efficient prompting is equal to efficient computation. So use structured, context-rich, minimal prompts to save inference time. So the people who are working in this domain, LLM, they are easily understand the inference time. So meaningful prompts lead to the lower compute waste and high accuracy. So comparing long with optimized prompt flow, long prompt flow, high token usage, more energy, longer response time. So we need to avoid such type of longer response time and the high number of token utilization. So that's why we need to put our query, that I mean to say, we need to redesign our prompt. So this is the cycle which will follow during the when we enter a query to the system, the single task with multiple task prompts. So JSON output based on the multiple task prompt. When we put a short query, I mean to say when we put a short prompt, then our short prompt convert into the NER prompt, and NER prompt convert to the named entities, then will pass to the JSON formatting prompt. So here the other route is the sentimental analysis prompt, and sentimental analysis prompt design the receive receive sentiment. So that will pass to the JSON formatting prompt. So this is the comparison between the single task and multiple prompt task. So here is the example which shows that the energy aware model training how important. So this we can use this type of functions when we use when we train our model. So the stop training when performance plateau, save GPU time and reduce power consumption, and promote the principle train until the meaningful,
Sorry for
not
the
until
interrupt.
exhausted.
You are basically such a wonderful session on it, but due to the shortage of time, we have to conclude in next 5 minutes if it is
Okay,
feasible
sure,
for you.
sure.
Thank you.
And here is the second example, the model quantization for edge devices. This is also a code example. If we use toss.quantization.quantize dynamic function, which will help us to decrease energy consumption. So it will compress model weights to use lower precision and enable AI inference on lower power IoT and edge devices, and also reduce energy use, extend device life, and minimize waste. So here is the third example. We can use the function. We can use the library code carbon. So this will help us to track carbon oxide emission during training models, raise awareness of the hidden carbon footprints of AI, and encourage transparency and environmentally responsible experimentation. So in this function, energy underscore cost, h dot energy underscore cost, we can use the allocate task to low energy node and optimize performance and energy trade-off. And in this example, the efficient prompt engineering for the LLM, we can reduce computational load by minimizing token count. So here is the summary of this talk. The sustainable practices. If we adopt energy-aware training, that will benefit us to the reduce CPU power use. And if we adopt the model containerization techniques, then we will take a benefit of enable lower performance and inference. And when we design such type of when we use such type of built-in function to reduce carbon tracking, we can promote transparency. So green scheduling also benefit us to the optimized distributed energy. So the future directions for those researchers who are working in the sustainable AI, they can focus on green AI models, sustainable data centers, AI for climate research, and circular AI hardware and ethical AI governance. So towards responsible and regenerative intelligence. So the main theme is of the this talk is the next generation of AI will not just be artificial, it will be available. So such a sustainable AI is not limitation, it's a direction of our innovation. So together we can design systems that learn smarter, act faster, and consume less. So final message is sustainable AI achieve with the smarter, greener, and purposeful driven computation. So each algorithm, prompts, and model choice can contribute to a cleaner digital future. So here is my email ID. If anyone interested to work in this domain, we can collaborate. So everyone anyone have question?
No, sir. Thank you so much, sir, for giving a wonderful session on sustainable AI. And we hope we will meet us again soon. Thank you so much.
Thank you.
Just 2048 is really modern in action. Dr. Tom Sabri and Big Valley is a distinguished scholar in data science with extensive experience across academia and research. He holds an MSc in computer science from Cambridge University and a PhD in computer science from the University of United Kingdom. Dr. Henry Valley expertise lies in applied artificial intelligence for energy efficient systems. Planning data science, data analysis, learning, deep learning, cloud language models, and generative AI. He has led contributions to target research studies in energy efficiency and has published widely in renowned international journals and conferences.
Welcome, Doctor, sir. Hope you are listening me. I'm audible to you, sir.
Hello?
Yes, sir. I'm listening to you.
All right, thank you very much. Yeah, I'm gonna share my.
Welcome back, sir.
Can you see
welcome
my
to, sir,
screen now?
Okay, sir. You can proceed, sir.
Can you see my screen?
Yes, sir.
Okay, thank you very much. Yeah, is it sharing now? Can you see my screen? Yeah. Hello?
Yes, sir. Yes, sir. You can proceed, presentation.
All right, thank you very much. Hello, everyone. So, and very welcome to the my presentation today and for the kind invitation. As you can see, my name is Noah Al Mitwalli, so I'm thrilled to be here today from University, Birmingham City University, UK. Today, we're going to go to embark an existing journey into the world of multimodality and generative AI in actions. In this session, actually, We're going to explore how AI is evolving beyond the traditional boundaries, learning to see, hear, and understand the world in much richer, more human-like way. Also, I'm going to delve into the some of cutting-edge research and practical application that my team and I have been working on, showing you how these advanced AI models are already making tangible impact. So, to guide us through this fascinating topic, here is a quick look at what we covered today. I'm going to start by grounding ourselves in fundamental of human intelligence, how AI combines different types of data. Also going to explore why this multimodality is so crucial, understand some concept of large language models, LLMs, and multimodality. So the heart of discussion would be about the research projects. I'm going to introduce today 3 case studies. And finally, I will be happy to, to share and to get your questions. So as you can see from the slide, so let's thinking about ourselves. So how do human understand the world? So it's through our 5 senses. Yes, we can see here touch, smell, taste. So each sense gives a different piece of information or a different modality of data now. So as you can see from this example, this croissant in the picture, which is very interesting, at least for us today. Just by looking, you can get some information from this slide. But if we also smell it, you can say it's buttery aroma. Your inside deepens significantly. So if you could taste it as well, that's where the real understanding the full picture comes in. So the more senses we engage, richer our comprehensive becomes. So what does this look like for AI? Actually, the multimodality, as you can see, is all about teaching machines to process and to integrate information from multiple modalities simultaneously, just like humans do. So instead of just text or just images or just audio, AI can handle all of them and even more complex data types like tables or videos. So as you can see from this diagram, multimodality, AI takes in audio, images, texts, and structured data from tables. There are many subfields, as you can see. And let's move to the heart of the definition now. So why bother, with all these complexities? So the benefit are immense. So firstly, more accurate decisions we need to get. So by combining text and images and audio, AI gets a much fuller and more comprehensive picture of situations. Secondly, better robustness. And thirdly, to improve the reasoning. And finally, enables advanced applications. So before we dive deeper into multimodality, let's quickly clarify what large language models. So large language models is a powerful AI model that have been pre-trained or on vast amount of data. So like library, internet. So their primary function is to understand and generate and process human-like texts. ChatGPTs, Geminis, and Metas, Llamas, all these kind of applications, would give us a rich view of large language models. So now let's put all together for how multimodality large language models, and I can give you a good example now about the different case studies from our research. So this is, I think it's been covered today by other colleagues. So I will skip this to the one of the main important research for today. So the first case study I'm going to introduce for you, it's about advanced development of customer assistance chatbot using multimodality large language models to enhance user experience. So what is this about actually? And the problem statement for this case study. So as you can say, it's been incredible. It can be incredible, tedious and time consuming, especially when the information isn't easily accessible. or you are dealing with a specific user manuals or piece of software. So our project directly address all these kind of pain points. So we are building a chatbot actually to assessing the information step by step, giving it the instructions, but also assist with the software installations, troubleshooting technical issues, and answering FAQs. So the proposed solution for that, by leveraging the multimodality capabilities or multi-agent approach. So what that means actually, it means that isn't just a text base. It can understand your questions, your type. So once you type the questions, speak to them, speak to the application or the agent, or even you can show an image. As you can see from the left-hand side, so integration of various multimodalities, input and an output. So let's move to the second one for a bit demonstrations. This screenshot actually showing the interactive user interface, part of a demonstrations environment. So as you can see, how a user has typed a question, how to create an animation for, this query. So the system processed this and provided a detailed number of explanations. According to the relevant image section, as you can see. So the second one, I'm gonna introduce what do you mean by this project is about, a smart building. So how is smart building for energy providing? And so as you can see, the background for this project, in our cities, we become smarter, how to optimize energy consumption. Yeah. So as I can, okay, thank you very much, but I can see some, a bit noise behind the scene. So in this case, in this slide, I would like to, focus on the smart building. So in technology, we try to enhance the structures that deliver a vast amount of sensors, data analytics, and information to create more efficient, safe, and comfortable environments. So think about this. So building today, actually, especially in the UK, produce huge amount of data from temperatures, sensors, occupancy, and light levels, and energy matters. So this evolution for that was broad, and the journey for AI itself was very challenging. So we've moved from simple reactive systems like thermostats turning on when the temperature hits a certain threshold to much more sophisticated environment. Let's move to the energy profiles, as you can see from this slide. So our specific aim for this case study in this energy profiling technology and project, we wanted to make energy consumption data more understandable and generate personalized recommendations. So this slide visually showing you the different profiles or energy profiles we've generated, showing case how different user behaviors and external factors influence the energy consumption now. So according to different profiles, profile 0 generating multi-generational households, profile 1 remote worker, and profile 2 retires empty nesters. Profile 3 showing the traditional families, for example, how much, showing the afternoon, evening dominance and eco-consciousness. The third project for today I need to introduce, it's about the impact and, let's, about enhancing, occupants comfortable. Yeah. So it's about, yes, this is the third one, as you can see. This project's been completed now, and it's up and running about multimodality and multilingual translations, AI applications using and leveraging generative AI speech translations to answer technical questions in IT support, cybersecurity. This slide actually showing you Viva applications. We built it actually. It's truly multimodality and multilingual generative AI. So the core idea is to provide a comprehensive support across over 100 languages, significantly boosting customer satisfaction now. So by leveraging these powerful LLMs and OpenAI, Mistral, Meta, AI, Hugging Face, all these kind of technologies, so to achieve substantial operational cost saving by automating a streamlining support processes. So let's move to the showing you behind the scene. So we applied these advanced applications and which is sophisticated agentic AI architecture, which is departure from traditional rules to a non-agentic AI workflow. So as you can see, and instead of just define step one leading to step two, step in, and so on, agentic workflow involves planning a phase where the AI makes a plan. So I'm showing you this good news about this application has become, it's going to be Noah now, according to my name. So this diagram actually showing you for the first time Noah architecture, it's neuro-operated assistant. So architecture to highlight how well these components come together in this architecture. So on the left-hand side, you see the chat UI, which is the interface where user can provide input, and the input would be in text or speech or image or videos, multimodality. This input flows through the LLM part, as you can see from this layer, which is the application layer, where speech is converted to text, and our multimodality and multilingual LLM process the query. This Noah, agentic layer actually overseen by supervisory or supervisor agent, then orchestrated various specialized agents. We have dedicated agents for IT support, cybersecurity, RAG, automated for retrieval, augmented generation with search and visions. Each agent actually leverage its own specializations database, like IT support databases or cybersecurity database to provide accurate, context-rich answers. And finally, the output, as shown on this slide, can be delivered as a speech or text, completing the multimodality and multilinguality and agentic interactions. So this is the last session, the last slide. Technically, so this is the live snapshots of our Noah agentic now, which is AI assistant in action, and it shows the demonstrate how user can ask complex technical questions about cybersecurity or any troubleshooting or any technical issues, and this is the live screenshot. So as we conclude, this is the last slide. Thanks for listening. I want to leave you with some thoughts in this field. So the future of AI actually, guys, is increasing, which is multi-agent AI and society of agents, where multiple specialized AI tools collaborate to solve even complex problems. So we next. I will be happy to thank you very much for listening today, and I'm more than happy to engage with you after this, event, and to answer any questions about how multimodality AI and creating opportunities for collaboration. Thank you very much for the kind invitation. Thank you.
Thank you so much, Dr. Nusal Sabri, for giving a wonderful session. There are some researchers basically who are sitting here and they want to ask one question regarding most frequently question. What open search problem basically in multimodal AI are most important for new researchers? Any
Yes.
suggestion?
Yes, actually, this is very important questions now. We are building and helping medical fields. So in medicine now, they are asking us to for a Dr. AI to help medicine students and to leverage the AI technologies. How this technology would help medicine students for surgery, and simulations. So all these kind of things, leveraging AI technology and multimodality actually will help the students in this field to be more interactive and to increase their knowledge and to understand everything in more depth. So there is a project now actively running with NHS in the UK, and basically the core of this application and the technical behind this is how to integrate the multimodality and leveraging the power of generative AI and large language models. So this is what I can say for one of the cutting edge and most important field. In addition to the cybersecurity now, and to cybersecurity is very important. The project I mentioned now, it's running, and it's been used by one of multi-winning award company across the country in cybersecurity now. They saved amount of money, that, and they build the customer support because rather than to facilitate and to accommodate customer support teams to answer the inquiries all the time. Now we can substitute them by just a simple chat GPT, and this model, and it will help to be available for 24 hours, 7 days. So this is one of the important topics. I hope I answered very well now, and
Yes,
I'm
sir,
more
sure,
than
sir.
happy to engage. Yeah,
Thank you so much, sir. Your answer will help us a lot for the new
thank you
researchers.
very
Thank you
much.
so much, Jazakallah, sir.
Thank you, though. Bye bye.
Cybersecurity and Intrusion Detection by Dr. Farhanullah. Dr. Farhanullah is an associate research professor at the Cybersecurity Center of Prince Muhammad bin Baaz University, Saudi Arabia. He holds a PhD in computer science from Saudi University and has served at leading institutions in China, India, and Pakistan. Recognized among the world's top 2% researchers for 3 consecutive years, Dr. Farhan has earned multiple awards for his research and teaching. He also contributed renowned journals as a guest editor and has published extensively in IEEE, Elsevier's, and Behavior. His expertise spans cybersecurity, malware analysis, data science, deep learning, and explainable AI.
Welcome to you, sir. I'm audible to you, sir.
Thank you, sir. Thank you. I'm hearing you. Can you hear me?
Yes, sir. Thank you so much. Yes, sir. You can proceed now, sir.
Okay, I'm sharing the slide. Thank you. Thank you. Can you see my slide, please? Is it visible?
Yes, sir. It is visible.
Okay. Thank you. Thank you for your invitation. Okay, let me start my. Okay, so thank you for your kind invitation. Thank you very much. My name is Farhan, and I am associate research professor at Prince Muhammad bin Fahd University at Cybersecurity Center in Saudi in Khubar city. I have done my PhD in computer science from Sichuan University in China. And after my PhD, I have done like 5 years of teaching in China in different universities. And then I have joined PMU like 1 year before here. So my topic is basically around data optimization in cybersecurity, because we have in cybersecurity, we have like a lot of real-time or dynamic attacks. And so we need to optimize the information in real time. Okay. So I will try to explore some research opportunities, and then I will also try to show you my research work in this presentation regarding my future and current future work. Okay, so outline of the presentation is like, first I will discuss about cybersecurity basics, and then what is intrusion detection, and then why we need optimization in intrusion detection, and then we will discuss about optimization algorithms, meta-heuristic algorithms, and then we will go through some examples of these methods in cybersecurity, and then we will also explore some examples of these, and then we will try to explore some directions. Okay, so yeah, this is the basic of cybersecurity. Okay, so a very basic concept, like for example, someone can obtain your like unauthorized access to your personal information, such as your bank accounts and passwords. or maybe hackers or people who are secretly access to your computer system to steal your information or any cause damage to your information, like in your phone or computers. Another is phishing emails. So phishing emails can tricking you by clicking on the link, and then they can steal username and password. So basically, I'm discussing here a very basic information in cybersecurity, how hackers or crackers or scammers can invite you and can steal information from your account and from your bank account, from your any email account, from your Facebook account. So they can steal information. So they can give you some attraction, and then when you click these links or maybe some software, some files, or download some files. So basically, they can attack on using those links or files in your computer. So introduction of cybersecurity. Basically, in cybersecurity, we need confidentiality, integrity, and availability of assets of digital informations. So using these methods, dynamic, we can design dynamic and adaptive methods for our research problems. Okay, so now defense against cybersecurity requires your actions. Okay, so we need to provide some actions, we need to provide some methods. If we don't care about these methods, the result will be grave. So we can be finished. Either we can we can lose access to computer campus computer network, or maybe we can lose access to our files in our shared folders, or maybe we can lose our information, our data, our research work, or maybe we can face some legal actions against us if we don't take care, if we don't care about these methods and actions problems. So basically, at the end, maybe we can lose our job if we don't care. So basically, we need to design some methods so that can help us to identify these actions, these methods, these actions or attacks from hackers. So how this is the simple visualization, how hackers can access your phone, can access your PC, can access your system tablets. So basically, they can spread some files or some links or something on your screen. When you click on those links, so they can access your files. This is
Yes, sir.
another.
Sorry for the interrupt. There is a voice issue from your side. Your voice is very low. Could you make it more?
Okay, let me check it, please. Uh, Let me check
Sir,
it.
yes, sir. Now it's fine, sir.
Is it clear now? Is it clear?
Yes, sir. Yes, sir. It's clear.
Oh, okay. Thank you. Thank you. So, what they need from your system, either they can steal your credit card information, either they can steal your username and password from your email, either they can steal any information from your PC. And after stealing this information, they can ask for the money. Basically, they need money from you. So, hackers are the educated thief. So basically, they can use some programming tactics to attack on your system, and then after this, they can make troubles for you. Okay, so another example. Okay, I need to. Yeah, this is example of like a real world example. Saudi Aramco paid $50 million to hacker when hacker attack on their servers. This is the link if you want to read more information. So basically, hackers attack on their servers. Saudi Aramco is a big oil refinery company in Saudi Arabia. So a hacker, they paid $50 million to recover their information from the hacker. So this is the real example how hacker can harm you, your company, your business, your information. Okay, another okay. Every year, the antivirus companies they provide the survey. For example, which viruses or attacks on their system. So basically, they provide a survey report every year. So I will show you some example here, some survey report. Like from 2023, we have 50% of SMS malware, SMS attacks, and then we have a 2% download and then we have 2% Tridia LC, then we have a 3% of like Marcher AV. So these are the survey reports published by antivirus companies. So it's like for the knowledge of the researchers. So researchers can design the methods for these type of attacks, because these are the trending attacks now from the hackers. Another survey reports from Kaspersky antivirus. Okay, so in 2023, they have published, for example, here 22. They have published like 55,000 tags on their servers. Okay, in Q2, and then in Q3 of 22, we have 35K, and then we have Q4, we have 48K, and then we have Q1 23, we have 57K. So basically, it's like evolving problems. When there is a known malware in the market, it is easily detected by the methods. But if there is unknown malware, like a 0-day malware, so it is difficult for the current antivirus. They can detect this malware. So basically, it's like evolving problem. So when there is a known malware, it's like a decreasing trend. But when there is unknown malware, it's like an increasing trend. So it's like every year we are facing different faces malware, different patterns malware, different patterns attacks. Okay, this another survey reports from Kaspersky here. So we can see like we have Q2, we have 405K, then we have 438, then we have 276, then again we have increasing trend. Okay, another survey report here we have in 23 Q2. So these are the name of the malware. If you can see my screen here, here you can see in Q1 we have 24% of risk tool malware, and then in the Q2 of in the same year we have 30% of the same malware. So then again we have adware, 34% of adware in Q1 23, and then we have 22% of the same malware in Q2 23. It's like a decreasing trend. And these companies basically they publish their reports for the knowledge, for the researchers, and for the academia. So and for the Windows, for the other researchers, so they can design the methods for the current malware. Again, we have this is another report from the Kaspersky. Adware 64%, and then again in the same year we have 62%, and then Trojan we have 18% malware, and then again we have 19% of malware in the same year. Like the green color is a Q1 and the red color is Q2. So I just want to show you which malware are currently trending in the market and using by hackers to attack on our PC and our phone. Okay, so this is another now if a researcher want to do a research, so basically now I will show you which type of data set we can use to design our own methods. Okay, so we have different types of repositories for the data sets. We have like Dirbin, we have like a Mel Genome, we have like a virus share, we have like AMD, we have like Andrew Zoo, we have like Kentico, we have different. But in my opinion, I will focus only 3 repositories. Like for example, Canadian cybersecurity repository, we have a Kaggle repository, we have a GitHub repository. Okay, so now I will show you some repositories. So if you are interested in this work, you can use datasets from these repositories to design your own methods. Okay, so this one is now this is the CSE, which is very popular. They publish their datasets freely available. You don't need to pay. You can just download their PCAP file, their APK file, their CSV file, and you can design your own methods to test your methods in your lab. So it's very easy to download datasets from here. And this is the publicly available, very standard. So mostly publisher accept this in your paper, and also for your PhD supervisor will like it if you use it. Okay, so this is the like a screenshots from the CSE. So if you want to use IoT malware attacks and some sort of PDF and some sort of like and malware, Droid, something. So these are the malware. These are the IoT based attacks or malware. These are the intrusion detection system malware, maybe attacks. Okay, so these are the different. If you click on any repository, you can download their all files in your folder, and then you can use in your research problem. So it's very easy and very like free. Don't need to pay. Before, like when I was in PhD, like 5 years before, it's really difficult to search a data set from the internet. Now it's very easy. You can just go the Canadian site and you can download any data set from the repository. Okay. Now it's very simple visualization. How many computers can compromise your system? So there is like, for example, your server may not reply to the genuine users. Okay. Another is this is another okay. In IDS, sometimes we have a signature-based patterns, and sometimes we have unknown patterns. For the signature-based, we need to design some methods. Okay, we can design for the both. Okay, so signature-based mean that, for example, we have a known patterns. We have already class labels, and we can design methods so we can classify the intrusions or attacks or malware using the known patterns. Sometimes we have unknown patterns. We don't have any class label. We just have a features and their behaviors in columns or maybe in their different files. So we can design the anomaly detection based methods, and we can classify those malware depends on their behavior or patterns. So in the second in this second method, we may not have a target variable. We may not have a known patterns of the file. We can just design our methods to read the features from the file and then classify depends on their behavior. Okay. So okay, now in traditional IDS methods, we have a static method which is difficult for the 0-day attacks, because in 0-day it's like a 0-day malware which is developed today. So there is no known patterns. Sorry, excuse me. So there's no known patterns. So basically, they are the 0-day malware. So it's really difficult for the current methods. So for the current conventional methods, they can classify the malware. So 0-day is a real challenging problem in the cybersecurity attacks. Okay, hackers can design a method. Hacker can design a malware which is a very like a new fresh malware and just spread on the internet. So there is no known patterns for this malware with the antivirus with the method. So it's difficult and they can easily attack on your system. Then manual tuning is really time consuming. And then we have a large scale and heterogeneous data. We have different types of features from different clients, from different edge devices, from different I2D devices. So it's difficult to design your methods and to handle this problem. So these are some limitation or challenges in the cybersecurity. Now, why we need optimization? Because of high accuracy, because of low false positive, and because of efficient resource usage. Because if you are using edge computing, so basically in edge computing we have a battery problem, like energy problem. So we have like energy resource constraints. So we need to design those methods. They can be lightweight and they can easily detect the attacks on your edge devices. So we need to do optimization. We don't need to run all the features from the clients. We don't need to run all the information. We just need to optimize the information to make it lightweight. So basically, these optimization are the meta-heuristic algorithm. These algorithm can design your optimized methods for the edge computing, for the lightweight. Okay. Now, we have different types of methods in a meta-heuristic algorithm. We have genetic algorithm, we have particle swarm optimization, we have like Ant-Colony optimization, we have simulated annealing, we have deep particle swarm. So we have different types of, maybe more than this. I just add a few of them here. So basically, these methods, the common goal is to optimize the features. So if we have like thousands or millions of features, so we don't need to process all of them. We can just use these methods to optimize these features and to make it lightweight, and then can go for the classification. Excuse me. Now, why we need optimization? Because of best feature selection, because of tuning to model like layers. We need to use a minimum number of layers. We need to use a minimum number of features, and we need to schedule the task. So if we have more number of tasks and we have limited number of edge servers, so we need to balance the task on the servers, and we need to balance the features on the server. So one server may not get all the load from the client. So we need to divide the task. It's like a task scheduling. So basically, these methods provide all these features for our design methods. Okay. So either we can go for feature selection, either we can go for model tuning, either we can go for task scheduling. Okay. So now, the first one is particle swarm optimization. It's like bird flocking behavior. So basically, they each particle adjust the position using local and global best. So basically, they can go like a bird flocking behavior, and they can find the best feature like this. Okay, so they have a fast convergence, simple implementation, and okay, sometime a local optima may trap the best features. So maybe one bird or one feature can compromise the whole problem, whole optimization path. Okay, so this is the problem in this particular swarm optimization, this method. Okay, so this is the cons of this method. Another is we have genetic algorithm. It works on the base of Darwin's theory of natural evolution. So basically, features can go for selection, crossover, and mutation, and then can go for best feature selection. Okay, so first we need to do initialization, and then we can assess the features, and then we can recombine and mutate, and then we can go for best feature selection. So this method links with the natural Darwin's theory. Okay, now here in this example, you can see we have many features now, but after some time we can go for the best features. So basically we have maybe 10,000 features, maybe 20,000, maybe 1 million features, and we can apply genetic algorithm to find the best features one by one. Okay, so this is the best way how you can use. Why we are doing this? To optimize the feature. So we don't need to use all the features in my experiment. We don't need to use, because sometime in 100%, maybe 30% are the useful and 70% are just noisy, noise information. We don't need this in our research, in our problems, and also for edge devices. So we can optimize those features which are really useful for our problem. Okay. Now, another example for the ant colony optimization. This is the another example of optimization. So basically, it works on ant colony pheromone-based path finding. How ant can find the best path, the same way we can use for IDS problems. So basically, network path optimization and anomaly pattern detection. So basically, we can find the best path for the intrusion detection or malware detection to reinforce the optimal route using ant colony optimization. Okay, so each method have a different patterns and different techniques to handle the problem. Okay, so we have pros, like we have a good exploration, handle discrete problems, and yeah, sometimes we have a slow convergence, and sometimes we have a perimeter setting problems in this method. Okay, another we have annealing SA method. Okay, so basically it mimics the metal cooling, where slow temperature drops find a stable states. So basically we can set a threshold in our method, and we can stop our selection, or we can stop our classification when this threshold achieved in this method. So basically, yeah.
Sir, you are giving such a wonderful session on a meta-holistic approach to strengthen the cybersecurity issues.
Okay.
We have to, due to the shortage of time, we have to conclude this presentation in 1 to 2 minutes. But with one
Okay.
question: can we use
Okay.
this meta-holistic approach in other medical imaging modalities or disease to diagnose a cancer patient?
Yeah. Yes, sir, we can use, because in every problem we have a feature problem, feature selection problem. For example, if you are using medical imaging, so basically we are dealing with the features. So sometimes we have, like, for example, if you want to classify the image, maybe 70-80% of features are not useful for your problem. So you can use these methods to classify your medical imaging using best feature selection. So basically,
Sure,
these
sir.
methods are, yeah.
Thank you so much, sir, for a wonderful answer and session. You just have 1 to 2 minutes to conclude this session.
Okay, thank you. So now these are now another is a deep swarm optimization. So basically, we are using swarm with the deep learning. Okay, so we can use the swarm with the deep learning to deal with the optimization problem in cybersecurity. These are some papers we have published as a first author or corresponding authors. Okay, so this is like an IEEE IoT. Recently published. This is a link of my paper, and we have used deep swarm optimization here to deal with the intrusion detection and IOVs. Okay, IOVs, unnamed aerial vehicles, UAVs. Okay, this is the summary of the paper. So I don't need to go deep in this paper. You can just get an idea. This is the link if you want to read this more. Another paper is this one we have published as a first author. And this is also another paper. We have used meta-heuristic algorithm with the genetic algorithm to optimize the task on the servers and to deal with the classification detection problems. Okay, this another problem. This is another paper. These are some graphs, okay, from this paper. So basically, we are running the optimization again and again, and we can until we can reach optimized solution. So basically, first we can 20 runs, and then 50 runs, and then 100 runs. So basically, if you are increasing the runs sometime, you will get the like a smooth curve with the best solution. Okay, so this is another paper we have published in the same area. So on all these methods, we have used meta-heuristic algorithm to classify the intrusion or malware on edge devices. Okay, so this is the summary of the paper. So here we are using images. Okay, so the question you asked before, here we are using images to classify the malware using genetic algorithm. You can see here. So we are using genetic algorithm to deal with the images. Images extract from the malware. So we have converted malware to images, and then we have classified images using genetic algorithm to optimize the task. This is another this is the overview of the paper in more deep, and this is another paper we have used like a meta-heuristic algorithm in IOVs. Okay, and these are the curves the optimization best features to make more runs and to get more best solutions. And these are the epoch curves, and this, yeah, thank you. This is the end of my presentation. Thank you very much. Any
Thank you
question?
so much. Thank you so much, Doctor, for a wonderful session. And hope we will again join and collaborate. Thank you so much, sir.
Thank you, sir. Thank you.
Security and over 27 years of teaching experience. Dr. Zahid has served on key academic bodies including the HEC National Curriculum Revision Committee. His research spans information security, programming languages, algorithms, enterprise architecture, and blockchain. He is also a dedicated reviewer for several high-impact international journals. Let's give a warm welcome to Dr. Amjad Hussain Zahid.
Assalamu alaikum. I'm Dr. Amjad Hussain Zahid, Associate Professor at the University of Management and Technology. I am honored and privileged that I have been the alumnus of Blue ED, and Dr. Muhammad Arshid Saab, he was my supervisor. I completed my PhD in 2019. And the topic of my thesis was related to the information security. So we have 15 minutes, 15 to 20 minutes. So I would like to have this interactive session so that you are able to learn something other than just sitting and learning nothing. So I request that please be attentive for 15 minutes. So any of you whose father is living abroad or doing job abroad, no. Assume a student is there whose father is living in USA or Canada or some other country, and he or she needs to pay. how he will share this data with the father. Either it will be WhatsApp, it will be an email, or some other medium. Assume there is an attacker, there is a person who is watching this conversation. What that person will do, what is the possibility? What that person will do? He will change account number. And instead of student account number, he will change it to his own account number. And instead of 5,000, 10,000, he will replace it with 15,000. Assume $15,000. Student earlier requested $1,000 and he is requesting for $15,000. Who will be at loss? Student will be and father will be at loss. So this is what happens whenever we share our data on the net or the medium that is generally unreliable. So what is the solution for this one? What is the solution for this one? The first solution is we should not share data on the net. Can we survive with this one? Can we survive with this one? Never. In the organizations, in the institution, in the university, you have to share your documents, you have to share your data with the Department of Control and Finance and so many departments are there. You are bound to share your data. And similarly, whenever you use social media, you share your data. Possibility is there. Any attacker is there, and he understands your data and modifies it and gets it benefit. What is the solution? We should share the data in such a way that it is not understood by the attacker. This is what is called encryption. So in case of encryption, what we do is we change our data. We change our data so that it is meaningless. It is meaningless. Not meaningful to the attacker. It becomes meaningless. So that is what we are discussing today. So we have the data. We need to protect it. What is that is called security. For that we will have to pay. We will have to develop some algorithms. And there are so many users on the channel. And one of them can modifies it and send it to the receiver. That is what is called man in the middle attack. Man in the middle attack. So these are the three major goals of information security whenever we want to protect our data. First one is potential. Second one is the ethical. What I was discussing that was the integrity is what? Whatever I send the receiver, that must be received by the receiver in the accept that one. And if we change it, that is an attack on the integrity of the data. Modification data is an attack on the integrity. How can an attacker change the data? If he is able to understand it. So what we do is we make his path to attack the data impossible by making data meaningless. And that is what if he is able to go for the group modification. If he is unable to understand, he will not go for the modification data. So this is the prerequisite. Confidentiality is the prerequisite. And similarly, for the organization to work 24/7, data must be available. So this is the whole picture and the scenario that is being used whenever we have the sender and receiver. What we do is we want to send our data. Look at the data that is meaningful. And similarly, we need a password to make it meaningless. And we will give these two things to the algorithm. And this algorithm is called encryption algorithm. Data sent on the channel will be meaningless. Data will be there, but we will be able to get meaningless data.
to attack, what he has to do, he will have to make it meaningful. And that depends on his key. So there are so many ways, so many algorithms to operate. Algorithms operate on a level or by level. These are called three algorithms. Some, but these are slower. Whenever you will change or operate on bit level, it will be slower. And similarly, we have the cipher algorithms which operate using more bits and bytes. And similarly, there are algorithms which use same password at the sender side and same password at the receiver side. These are called splitters. And there are also algorithms which use the medium mathematics to encrypt with one key and decrypt with another key. These are called splitters. And one of the algorithm is RSA, designed by three mathematicians, Rivers, Speed, and Edelman. And that is being used in industry by 20% of the industry. Unluckily, that has been broken. RSA has been broken. We will see. And similarly, so today's talk is about the spectral ciphers. And look at the history of the ciphers. These are the algorithms which have been there in the history of the civilization of the mankind. First cipher, the usage of cipher that had been reported. 1900 before Christ, as the Sir Islamic that spread. 1900 before Christ. And similarly, there is very popular cipher, Caesar cipher. That is very simple cipher, but used 100 before Christ. And similarly, a modification of that Caesar cipher is beginner's cipher. And that was used in 16th century. And one of another cipher that is Hill cipher that was used in World War II. And that uses the knowledge of matrices, simple matrices multiplication. And then 1970s IBM designed a cipher. First it was named as Lucifer, and later on it was named as Data Encryption Standard. And that was actually adopted by the English National Institute of Standards and Technology, and they named it Data Encryption Standard. And then later on, RSA cipher that was done by these three persons in 1970. Look at the OS model. How many layers are there? 7 layers. And cipher on layer. And each and every layer there is an encryption. But major encryption is at presentation layer. Listen, these 7 layers out of these 7 layers. 6 layers we have the encryption. And one of the major encryption algorithm that is used, that is a presentation layer. And then in Google, these two developed another cipher that is being used in the industry. 50 to 60% of applications in the industry are using this advanced encryption standard. Why? That is what we are going to discuss. So look at whenever we think about an algorithm to criticize students, algorithm is actually a collection of steps performed in an order. So there will be the operation of patient 1, operation 2, operation 3, and so on. So ciphers do what? They use only shift operations, they use XOR operation, they use substitution operation, and similarly use permutation operation. Look at, we see two of the major operations which are used in the ciphers. One is called permutation and another one is called substitution. Look at if we have the data support. These are the two permutations that which are given here. Here are मैं बता दूं कि नहीं The community is has been my student. For the full 2001. I still serve. I am so pleased and honored to be there in case in the industry where I have completed my PhD. Glad to see. So these are the permutations, okay? And similarly, whenever, so what we do is in the permutation, we change the place of the characters or the bits or the bytes. School has been permuted as OS and HSO and similarly another one. Is it possible that the attacker is able to get the original data school? Is it easy? Yes. What we are able to will change the place of the characters, and at some point of time he will be able to get school. School was our original data. But in case of substitution, what you do is you replace some data with some other values. Look at school that has been replaced with two other strings. OR, question mark, TH4, and similarly another one is P, W, M, and so on. So which one is difficult part? And which one is easier one? Anyone? Excellent. Second question. Very excellent. Look at the number of possibilities he or she will be able to perform to get the original data. 6 factorial, 720 possibilities he will have to try. This is what is called brute force attack. Each and every possible combination. And what about? So we have school and we have replaced. So we will have 256 8 power 6. What we will get is, if you look at S will be S is a byte, and byte has 256 possibilities from 0000 to 1111. 256 possibility at one place, 256 possibility at second place, 256 possibilities at third place, and it will be 256 multiplied by 6 times. Look at the number of attempts he will have to do. It is more than trillions or billions and so on. What will be your choice whenever you design your own goal? Competition or substitution? Exactly the choice. Oh, we use a table. We use a table that is called substitution clause. Yes, that will give you the best of part. More than 50% of applications in the security, in the banks and telecoms, in the defense sectors. Even your WhatsApp. Yes, yes. First version is in which we use 128 bits. Second one is 192 and third one is 256. And that is are stored in the applications. And similarly, you have the scan and so many applications are there. So the building block is this one is it uses 128 bits of data. That is 16 bytes. It gives 16 bytes of data at each step. The usage of A is 50 to 60% in the industry for the security. All the banks, telecom sector, WhatsApp, social media, they are using it. I have already told you that R is has been broken by quantum computing. We'll see what will be the state of AES. How many operations are there for AES? There are 4 operations. Look at how many operations are there? 4 operations. 2 are very simple. First one is the listen. Look at this operation. This is our shift operation. What about the state of matters after this one? First row is exactly the same. Second row is this 4 series will match into the left side. So 2D will be here and so on. This is kids task. Very simple. AES being used in many security applications, and this operation is very simple. And another operation that is there, XOR operation. That is very simple. We have the data, we have the key, and we perform XOR operation. It's in the what we waste. That's 0. And if it's are different from that, we have that is 1. So this is very simple. These two things are very simple. And how many operations are left? How many operations are there? 4. Two operations are very simple. It means the security of AES factor lies depend on two other operations. Look at the third operation, that is mixed column. This is also a simple simple matrix multiplication. That is also is 0. And AES is being used in 50 to 60% of security applications in banks and in military and so on. Security lies on part. Only one operation, that is what is substitution of funds. Substitution of funds. What is a substitution box? It is actually a table. It is a relationship between inputs and outputs. It is a table to be designed so that what will be replaced by what. So very simple example is if I want to replace one bit with one bit, can you tell me how many possibilities are there? There are only two. One bit must be replaced with one bit. First possibility is this one. Look at this. 0 is replaced with 0. 1 is replaced with 1. And another can be 0 is replaced with 1. And 1 replaced with 0. What you will choose? First option or second option? What is the problem with the first option? It does nothing. So, if you want to convert or change one bit to one, there are only two possibilities. There is no other possibility. So, this is what is called substitution box. This relationship is called substitution box. So, there are only two possibilities. It can be written in different ways. First one, second one, third one. What we are going to do is, we want to replace it. 2 bits with 2 bits. My question is it easy? How many combinations of 2 bits are there? 4 combinations. It will be 0, 0, 0, 1, 1, 0, and 1, 1. So it seems quite how many S blocks will be there? For 1 bit, it was 2. For 2 bits, 2 bits, how many S blocks will be there?
Yes. 4. Excellent. 4. Excellent. 24 possibilities will be there. 24 possibilities will be there. Look at the first row. 0 is replaced with 0, 0 is replaced with 0, and so on. 1 is replaced with 1, 2 is replaced with 2. This is one possibility. Second one is 0, 0, 1, 1, 2 is replaced with 3. 3 is 1. And 3 is replaced with 2. What about this choice? It is the weakest one. It is the weakest one. So 24 possibilities. Excellent. 100% weakest boxes. But you will never use it. Never use it. Then similarly we have 50% weak S boxes. What will be these S boxes? 50% weak S boxes. Can you tell me any S box do 50% would have weaker than? Look at this one. Look at this one. 0 is replaced with 0, 1 is replaced with 1, 2 is replaced with 3, 3 is replaced with 2. Out of 4, which one are effective one? Only 2. 50%. And similarly, we have strong S boxes, these are 9 S boxes. Out of these 24. What if we want to replace 3 bits with 3 bits? How many possibilities? possibilities? How does it appear? How it has been calculated? 9 factorial, excellent. 9 factorial. You are near. It is 8 factorial. How many bits are there? 3 bits. We want to convert replace 3 bits with 3 bits. And what are the choices? 2 raised to power 3. 3 bits contain 8 values. So there will be these possibilities. And this is one of the formula that is being used in industry in mathematics for the permutations. So these are the preferred choices. 1 bit is converted to 1, is replaced with 1, 2 bits with 2, 4 bits with 4. What about if we want to use 3 by 3 S boxes? Problem will be there. File size is always in the multiple of bytes, and bytes has bits. It is a multiple of 8. So 3 by 3, these will not work. So today we are going to we use 8 by 8 S boxes. And my PhD research thesis was I designed an S box that was 8 by 8 S box. That was one of my contributions. If I want to replace 8 bits with 8 bits, how many possibilities are there? For 3 bits it was 8. What about 8 bits? Excellent. 256 factorial, not 256. Excellent. 256 factorial possibilities are there. And what I will use is, I will use one of the S boxes. And attacker will have to try 256 factorial possibilities. It is a very small number. This is one of the example. This is one of the example S box. I will replace 0 with 121 will be 250 and so on. This is random permutation of things. 256 factorial is a great number. 507 digits. So there are 2 types of S boxes we use. One is static S box and another one is dynamic S boxes. Time kitna lagta? Bas 2 minutes off. One is called static S box. That is actually a fixed arrangement of values. Like we had this one. And if I fix this one, it will be called static S box. And if it is stolen by anybody, your whole encryption process will go in van. What today we do is, we go for the formula. We develop a formula and in which we use variables and values are get by from the key. And we change the key, and attacker will have to have the knowledge of the key. And it is obvious that we will have to keep our keys. So this is one of the formulas that can be used. I will discuss this one in a minute. S box must be strong one. These are the 2 requirements, and it must be generated in an efficient way. These are the few properties which we must test whenever we design an S box. How to generate an S box? There are different techniques, and my research was, or my area of research was that was using polynomial transformation. I will discuss this one. This is one of the area in which we design S box, linear fractional transform, LFT. Then another area is Galois field. AES has been designed using Galois field. This is quite a mathematics. What about this equation? Linear, line, linear. What about this one? Quadratic. And what about this one? Polynomial, cubical polynomial. And this is what I have used in my PhD thesis. This is the small and the simplest ever equation, polynomial, that has been used by any researcher. 2019 मैंने use. It seems to be very easy. मेरे 2-3 साल खा गई ये equation, simple बनाने उसको.
whenever I will have 0, value of byte is 0, it will be replaced with 40. Whenever we will have 1, it will be replaced with 127, 2 will be replaced, and this is what is S boxes being generated. So, and Dr. Mohammed leadership. He is younger than me. Usse 5-6 saal, 10 saal, and he is my supervisor. This is the beauty of knowledge. Other area that is being used, chaotic maps. And these are actually the recurrence relations or recurrence equations. We use previous value and we get next value, and again this value is being used on the right side. Another paper we designed, we published, that is this RAM map. One of my students doing PhD with me, Rehan, then my name Amjad, and then my class fellow, Dr. Ghulam Mustafa. Luckily, he is also an alumnus of UVT. So this was a simple algorithm to design. We have used this chaotic map, and another approach that is being used, that is called hyperchaotic map. We use different dimensions, different variables. That is what is the current trend in cybersecurity or SBOX design. Last statement. Quantum computing. Very burning question. Whether quantum computing will be able to compromise the security of SBOXes or the security provided by SBOXes. RSA has been broken. So all the applications which are dependent on RSA, they are at stake. Look at, I did ask the ChatGPT system, please tell me, and then 8x8 SBOX has 256 factorial possibilities. Will it be broken by quantum computing? What is this one? 256 factorial is 10 raised to power 506, and it is equal to 10 is equal to 2 raised to power 3 point something. So this will be 506 will be equal to this one, near about this one. So very huge number. If you try each and every possible combination, it will not be broken by classical supercomputers. It's okay. What about the quantum computer? It generally takes the operations in this range. Classical computer is taking so much time, it will be the under root of this operation. This will be this one. So, if a computer is there, quantum computer is there that can perform operations, 1 trillion operations per second. 1 trillion operations per second. So, it will be going for this one, 2842 possibilities, time in 1 second. So many possibilities are there. 10, 12 will be equal to 2 raised to power 40. So 2842 minus 40, that will be 2802. It will be trillions of trillions of trillions of trillions of trillions of centuries of years. And what is the age of universe? That is this one. So SO box will not be broken by quantum. Last slide. Thank you for bearing me. How to secure your data? This is my big question. How to secure your data? Sir, not mine. Develop an S-box. Develop an S-box. And let the attacker try what is the S-box that is being used. Thank you very much. It is my honor. Jamshir साहब तशरीफ है काश साहब थैंक यू इन्होंने मुझे इनवाइट किया कोई क्वेश्चन है
As I could give me this lighting session, Dr. Nadeem Sarwar from Bahia University, Lahore, Dr. Noor Sabri from Birmingham City University, UK, Dr. Amjad Hussain from UMP Lahore, Dr. Farhamullah from Prince Mohammed bin Fahad University, KSA. My sincere appreciation also goes to the organizing committee for the flawless coordination and support ensuring the smooth execution of this session. I am deeply grateful to our attendees for their active engagement through sessions. It is an honor to be served as a session track chair. I hope this idea shared today will inspire new collaboration, foster innovation.